You're listening to the Australian Water Association podcast series. My name is Jo Taranto, and joining me is Sandeep Sathyamoorthy, who is the Process and Innovation Leader at Black Veatch. And today we're discussing taking mainstream deammonification out of a box and putting it into practice. Welcome, Sandeep.
Thanks, Jo. I appreciate it.
Now, look, you've been with Black Veatch for 4 years. Can you tell me about the sort of work that they do?
Sure. As a company, we're consultants. We work globally in the water sector, energy, telecom. I'm in the water space, and as a company, we work across the world in Australia, New Zealand, Singapore, so the Far East. We're based in Kansas City in the US. We have a good footprint within water. We do work both on the wastewater side, water, recycled water, both non-potable and potable reuse. And we also, work on big dams and tunnels and so on.
And I think one of the interesting things about the way your organisation's structured is that you actually also have a research group that's kind of in-house as well. Can you tell me about that?
Yes, absolutely. Yeah, we have an innovation platform group, which is our collaborative applied research program. It's relatively new. We're growing it. In fact, we just built a water innovation center in California. And the idea there is, we've been working, we're a 100-year-old company, and along with others, we've really been pushing the boundaries very consistently of what we can do with water, thinking about the future of a water droplet. Where is it going? Where are the resources going? And so on. And so we see with all the clients we work with across the world, there's a movement where we're trying to convert our conventional wastewater plants, what we used to think of as wastewater plants, into true resource recovery facilities, part of a circular economy as a whole. And that requires a lot of energy, a lot of input, and a change in the philosophy. So what we've established a few years ago is a research program where we invest our money to try and think about solutions, processes, approaches, strategies to make this transition happen. So then we can take them, having vetted them and proven them, take these ideas to our clients and say, we think this is a good path for you to take. So it allows us that flexibility.
And so the topic we're talking about today really comes off the back of the innovation platform that you guys have been running. Can you tell me what deammonification is?
Yes, absolutely. So let me maybe take a short aside and say, conventionally when we think about managing nitrogen in the environment, which we don't want it to go into our waterways and so on because it causes harmful algal blooms and the like. And so conventionally, when we take it out, we do a multi-step process, which is very energy intensive. It costs a lot. And, is it sustainable? You really have to ask that question. So in our treatment works, 60%, somewhere between 50 to 60% of the energy input, and therefore greenhouse gas footprint is tied to managing nitrogen. So deammonification is an approach, is a process strategy, as well as it's on the back of a bacteria called Anammox that allows us to basically reduce the energy cost of doing the nitrogen removal.
And it's a natural biological process.
Absolutely. So the Anammox bacteria occur everywhere in the world. They're naturally occurring bacteria. So it is all about fostering the right environment for them to thrive and be successful. And that's what the deammonification.
You've developed, a pilot for a type of biofilter, is that right? Or you're trying to look at the best applications?
That's right. So the technology is actually from a Korean company called BKT. So they have a biofilter technology, and we collaborated with them to assess its use in mainstream deammonification. And mainstream is very particular in that it has certain challenges given the concentration of nitrogen in the feed and so on. So it's a novel application. There really isn't any good existing examples of this in the world. So our work was really taking, propelling this nascent technology and concept forward, we think.
You took a plant in California.
Yep.
And you created a pilot biofiltration
Yep.
system. So what did that
What do we do?
process involve, and what
Right.
what were the outcomes there for you?
So what we did is we actually took the secondary effluent from an existing BOD removal facility, which has a lot of nitrogen going out. And through some previous work, we thought, okay, now we should be able to deammonify it. Honestly, it didn't work at first. And as things go, and I joke about this with folks, we did what a good scientist would do. We said we'll cheat, and so we try. Jokes aside, we really said, okay, we think we understand why it didn't work. So let us, for the moment, treat this as a proof of concept experiment. And so what we did is we took this secondary effluent, high in ammonia, we added nitrite externally, and using this now blended stream, we said, okay, if we can get this stream to be deammonified by Anammox bacteria in the biofilter, we know that then we can take a step back and figure out how to make the right nitrite ammonia blend naturally. So that's what we did. We ran the process for about 8 months or so. At a range of loading rates and flow rates, and got tremendous results. We were just thrilled with what we saw. To contextualize it a little bit, the loading rates in terms of how much nitrogen is applied on the process that conventionally in the community of practice that we're used to is around let's say 1 kilogram of nitrogen per day per meter cube of the reactor. We ran our system up to about 7. So 7 times what we are used to in a complex stream with great success, showing about 80% removal or so. And so what we think we've shown is that this process is conceptually viable. There are certainly trade-offs to be considered, operational as well as technology, as well as options. So it's not just about the trade-offs, but this is a big conceptual step forward.
So what are some of those potential indicators and then trade-offs, I guess?
And some challenges as well.
Yeah.
Maybe. So, the indicators, when we think about how much energy, so if we start to measure consistently how many kilowatts, how much power does it take to remove nitrogen from our wastewater and then send it out to the environment or use it for potable reuse and so on, we can reduce that by between 25 to 30%. So that has a significant operational benefit for utilities, but also when we think about sustainability, a greenhouse gas benefit. These are substantive KPIs that we can use. There are, however, trade-offs, right? We don't have, this is not a 100-year-old process. We don't have existing facilities. We don't have the know-how, right? These are new. We've only known about these bacteria for less than 20 years, right? And being able to engineer systems around them for less than 10. So it's relatively new in a field that's so well established. So the know-how has to come. There's also a little bit of a technical challenge, which is there's another bacteria which actually competes with Anammox very effectively. And managing that competition is the science and engineering art and challenge. And this is what we're focused on now, actually.
Okay. So that's the future direction for this right now?
Absolutely. So not just with us, with others too. The future direction is to take this technology and address all the trade-offs, address all the challenges, and say now we have solutions that work that we can implement on the full scale to be able to give utilities and the water corporations, the SA Water and so on, solutions which are really robust and resilient.
We've been talking to Sandeep Sathyamoorthy, who's the Process and Innovation Leader at Black Veatch. Thanks so much for your time.
Thank you so much for having me.